Hello friends, welcome to the spoken tutorial on Firebird 5 robotics research platform. This platform is based on ATmega 2560 microcontroller, which belongs to AVR architecture based microcontroller family. In this tutorial, we will learn the basic I/O interfacing on Firebird 5 robot. Now let us see the agenda for discussion in this tutorial. The presentation will start with the discussion of input-output ports of ATmega 2560, which includes the overview of the ports and method of accessing the ports with the help of examples. Then we will learn how to write our first embedded C program for the buzzer interfaced on the Firebird 5 robot. So what are ports? Ports can be defined as junction where peripheral devices can be connected. Peripheral devices can be classified firstly as input device. Input devices are the devices which give signals to the microcontroller. So example of input devices are switch, sensor, etc. Other peripheral device is called as output device. Output device are devices to which the microcontroller will send the signal. Example of output devices are buzzer, LCD, motors, LEDs, etc. Let us now see the ports present in ATmega 2560. So ATmega 2560 is a 100-pin microcontroller, out of which 86 pins can be used as input or output pins for I/O interfacing. These pins are grouped together and are called as ports. The pins are called as ports because if you want to access any of the peripheral devices, you have to do it by putting the address of it, that is, to which pin particular input or output device is connected. So addressing 86 pin is very difficult. So we have grouped the pins and have called them as ports. In ATmega 2560 we have 10 8-bit ports named as PORTx, where X is the name of the port and X will vary from A to F and H, J, K and L. ATmega 2560 has one 6-bit port which is named as port G. All ports can be configured individually as input or output pin as per the device connected to it. Now let us see how to access the port. In AVR architecture, each port has 3 registers associated with it. So we have to use these 3 registers to define each port which we are going to use. The first register is DDRX register, where X can be replaced by the name of any of the port register, that is A to H and J, K and L. The second register is PORTx register, and similarly we have third register which is called as PINx register. So now let us study each of the register in detail. So first register is DDRX register. DDRX register stand for data direction register. The purpose of this register is to set the port pin as input or output. If we assign the value 0 to DDRX register and we set the port pin as input pin, similarly if we assign the value 1 to DDRX register, we set the PORTx pin as output pin. Let us see an example for getting more clearer concept. Suppose we need to make port B lower nibble as input and upper nibble as output. So for this, what should be the logic? Logic for it would be to assign the value 0 to the port pin D0 to D3 and value 1 to pin number D4 to D7. We represent the value in hexadecimal notation, which will give convenient and standard notation while programming in C language. So here the value is written as DDRB is equals to 0xF0. Now let us consider the PINx register. The purpose of this register is to read the value from the input device connected to the port pin. if we define a port as input port, then we read the values present on the input devices using the PINx register. The value read from the PINx register is to be saved in a user-defined variable. Let us consider an example. We need to read the data from port C register. Suppose port C has following bit pattern. So the steps would be to define a variable. Here we are calling it as x. Then we perform x is equals to pin C. So the value of register port C will be stored in a variable x. In this case, the value in x would be 0xF0. So you can read any value stored in the register using pin register. Now let us see the third register, which is PORTx register. PORTx register operate in two different ways depending on the way in which the port is defined. First case is if port is defined as the output. We use port register to output desired value to the output device. For example, here we defined port A as output by assigning the value DDRA is equals to 0xFF. In this case, if we assign the value as port A is equals to 0xFF, which means the logic high to the device connected to port A. Now suppose if the device is LED, then the LED will glow on the logic high. Similarly, if port A is written as 0x00, LEDs will turn off. Now let us see the second case. In this case, when the port is defined as input port, in such case the PORTx register is used to activate or deactivate the pull-up register. So what are pull-up register? Pull-up registers are used to assure that the input to the pin is maintained at a desired logic level, even if no active devices are connected to it. This is done to avoid any external noise or interference to our reading and hence to minimize the error. So to activate the pull-up register, we assign the value as PORTx is equals to 1, and to deactivate it, we assign the value as PORTx is equals to 0. Let us consider an example now. In this, we make port A as input port using DDRA is equals to 0x00. Then to activate the pull-up, we assign port A is equals to 0xFF. So the pull-up register is activated for all the pins of port A. So we now have covered the overview of the ports and how to define the port using register. Now let us understand the concept with few more examples. Consider example 1, where we need to make port D as output port and send bit pattern of D5 to it. So the steps involved in the example will be as follows. First step will be to make port D as output port. So value in DDRD register will be 0xFF. The second step will be to put data on port D register. So the value in port D register will be 0xD5. Let us now consider the second example. In this, we have to make port A as input port with pull-up activated on all the pins. So the steps involved in the example will be as follows. First step will be to make port A as input port. So value in DDRA register will be 0x00. Then second step will be to activate pull-up register on port A. So value in port A will be 0xFF. Let us now consider the next example. In this, we have to make upper nibble of port D as output and lower nibble as input. Then we have to output value 3 on upper nibble and read back data using pin D. So the steps involved in the example will be as follows. First step will be to define port D pin 7 to pin 4 as output and pin 3 to pin 0 as input pins. Therefore, value of port D register will be 0xF0. Then the second step will be to put data on port D pin 7 to pin 4 and enable pull up for pin 3 to pin 0. So the value of port D register will be 0x3F. The last step will be to read data from port D register. This will be done using pin register. So we can write x is equals to pin D. Therefore, value of x will be 0x3F. With this, we complete the configuration of port in details, and we can now begin with our first program. The first program in this tutorial is to interface the buzzer on Firebird 5 platform. Buzzer connected to port C pin 3. This is a simple diagram of buzzer connection in which buzzer is connected to PC3 as shown in the figure. To turn on the buzzer, we send logic high on pin 3 of port C, and to turn off the buzzer, we must send logic low on pin 3 of port C. Now let us proceed with writing the program. So we should first configure port C pin 3 as output. So this is done by using DDR-C register. So value of DDR-C should be 0x08. Now to turn on the buzzer, set port C pin 3 as high. So value of port C will be 0x08. And to turn off the buzzer, set port C pin 3 as low. So value of port C will be 0x00. Let us now look at how we are going to write the program. For writing microcontroller program and making it work on the robot, we require few tools. Here we will have brief introduction to tools required for programming the AVR microcontroller. The software required are ATmega Studio 6. It is an IDE which stands for Integrated Development Environment. An IDE typically consists of an editor, debugger, compiler and an interpreter. ATmega Studio supports developing and debugging of AVR and ARM-based microcontroller application. We will write the program in C language and compile it in the ATmega Studio to generate the hex file, which is the machine language understandable by the microcontroller. So ATmega Studio can be downloaded from the given link. After generating the hex file, we need to load it into the memory of microcontroller. For this, we need a hardware device. So the hex file can be loaded into the microcontroller using the hardware such as bootloader or AVR programmers such as AVR MK2, AVR Dude or Pony programmer, etc. Well, let us now begin writing the C program. In coming slide, we put the syntax for writing the C program. So the standard C program begins with including the header files. Here in this program we include some of header files which are has include avr/io.h, has include avr/interrupt.h, has include util/delay.h. Next, we need to configure the port pins as input or output. We are using a function defined as buzzer_pin_config. Then we assign the value to DDR-C register in a way as it was explained earlier to make buzzer as output device. And value of port C will have the initial value as 0x00, that is initially switch the buzzer off. So we have intentionally not written the value here, you should fill it yourself. Now let us define the main program. In main function, initially we have called the buzzer underscore pin underscore config function. Next we have called an infinite while loop in which we call the function buzzer underscore on to switch on the buzzer. Next is the delay function written as underscore delay underscore ms, which has the parameters to be sent in the millisecond to introduce the required delay, for which buzzer should be high. Next we call the buzzer underscore off and then again give the necessary delay. So this function will be called in the while loop, making the buzzer on and off at particular interval depending upon the delays. Now let us look at the function defined in the main program. It is always a good programming practice to write the code by making different functions. So the first function is of buzzer underscore on, which will have the high logic stored in port C register. The second function is of buzzer underscore off, which will have low logic stored in port C register. Now let us look at the demonstration. We will start with writing the C program for buzzer interfacing in ATmega Studio. So open the ATmega Studio by clicking on the icon. So let me do it. You can click on the icon from here. So we have already created the project for buzzer programming. You can refer to the tutorial on ATmega Studio for knowing more details on how to create projects and other relevant details. So I have here written the program in the editor. You can write the code by yourself on the editor which you are using. So as you can see here, the code is same as explained to you in slides. However, I will be explaining you each of the lines individually. So the first line here is written as has defined f underscore CPU 14745600. This line sets the clock frequency at which microcontroller is working. Its value is determined by crystal oscillator attached to the controller. In Firebird 5, crystal frequency is 14745600 Hz. You can change the value if your crystal oscillator is different by just changing this line. Now next instruction are for including various header files. So I have included the 3 header files here. Then this is the function for buzzer pin config. So it configures the buzzer pin where buzzer is connected as output pins. So now this is the operation concept of masking which is used here. So masking is done to set only single pin while we are working, and rest of the pin is left in a previous state unconnected. Okay, so now this is the function for switching on the buzzer. So here we have written port C is equals to 0x08. So this will put a logic high, that is the value of 1 on my port C pin number 3. Then this is the buzzer off function. So this will put 0 value on port C pin number 3. Then this is the function for init underscore devices. Now this is a standard function which we will be using in all the programs. Now this function calls function which configure pins as output or input, and it calls other functions which are used for hardware initialization. So in this case we are not using any hardware initialization. Later when you use PWM or ADC, at that time you will see how we use those also. Now after this we have a main function. So in main function I have called this init devices, the first statement, and then inside an infinite loop I have written buzzer on. So this line will switch on my buzzer, and then a delay. So buzzer will remain on for 1 second, and then buzzer will go off and it will be off for 1 second, and after 1 second again the buzzer will be on, and so this loop will go on infinitely. You can change the logic by changing the program. So you can make buzzer ring for 10 times by using for loops, etc. Now after completing writing the code. Next step is to build the program for generating the hex file. For this, click on the Build tab at the top. Inside that, click on Build Buzzer. Once you have clicked Build Buzzer, you can see the process going on in the output window at the bottom. So once build is complete, you can view output window which shows the status. So here it is showing build 1 succeeded. So one file has been successfully built. Okay, now after building we are actually generating the hex file. So you can look in the folder where the hex file has been generated. Now let me just introduce a error here and let me show you how to tackle those situations. So I have removed the semicolon from here. Now I will try to build it again. So as you can see here, a error is coming. So double click on this error. It will give you the location where the error is. So as you can see here, we have to put it's pointing that we have missed a semicolon. So just introduce the semicolon and then try building it again. So you will see that the build will succeed. So in this way you can troubleshoot various programs by looking at the output window and try to troubleshoot the errors which are coming. Now the hex file for the code is generated. So you can view that hex file in this buzzer folder which is created. Inside this debug folder you can see a Intel hex file which is created. Now we have to load this file into our robot. So for this you have to use a AVR bootloader. So you have a software called AVR bootloader. So double click on AVR bootloader software and then provide the necessary details. So you have to give the COM port number, then give the baud rate as 115200, then select your microcontroller which is in our case as ATmega 2560, then browse for your hex file. This is in our case is at the desktop on buzzer folder, debug Intel hex file. Now you have to switch on the robot and invoke boot mode for loading the program using bootloader. So boot mode is invoked by pressing and releasing the reset switch with boot switch pressed, and then release the boot switch. Now click on the program button in AVR bootloader. You can see the LED blinking, which means program on your bot has been successfully loaded. You can see here also when it shows equal leaving programming mode, it means your program has been successfully built. Once hex file is completely loaded, press reset button or switch on of your bot. The program will now work and you can see its execution on the robot. If in case you face problem in hex file getting loaded using AVR bootloader, try troubleshooting by checking COM port number or reinserting the USB cable and restarting the bootloader software. Here we have successfully understood the concept of port operation in AVR based microcontroller and have written the program for ringing the buzzer. So with this we have come to the end of this tutorial. Thank you for listening. For any queries or doubt you can visit qa.e-yantra.org.